Now, the final program I have for us today is to draw a chessboard. And what I want to do is I want to be able to write a function that draws this. Now, I want to be really clear that this is advanced. If you followed the lecture up to is odd, that's all you need. And this is just kind of like an extra piece of advanced material. But maybe you'll find it interesting, and I wanted to put this content out there because I thought some people might find it interesting. But it's up to you if you want to go down this path. But shall we try this? So our last program today is to draw a checkerboard. Now, to draw a checkerboard, I want to be clear that it's a lot of work. So instead of just trying to do the whole thing at once, a really mature thing to do is to set some milestones so we can test as we go. My first milestone is, can we just draw a row of squares? My second milestone would be, can we draw a grid? And then the third milestone is, can you figure out how to checker it? Okay, so we want to do these different milestones. We've got milestone 1, draw one row. Once we've drawn one row, then we do milestone 2. We want to draw this whole grid, and then finally we'll figure out how to checker it. So if you want to draw this first milestone, I've set up a for loop. It clearly feels like something we want to be repeating. There's 1, 2, 3, 4, 5, 6, 7, 8. And so what I wanted to do is I wanted to set up a for loop. It runs 8 times. That's the number of columns. If you don't remember, columns are the names of these vertical lists, and there's 8 of those columns. And so 8 times, I want to draw one of these squares. And every time I want to draw a square, I'm not going to just write the logic in here. I'm going to use one of these functions. And the function wants to take in parameters. Right now, it's going to take in the canvas, the row, and the column. So this is row 0. This is row 1. This is row 2. This is column 0. This is column 1. This is column 2. This function is going to be so useful. You can give it any row and any column, and it will draw a square at exactly that location. But it doesn't exist yet. We have to define it. So if we want to define this function, we want to be able to do something so that it draws. So right now I've set up this create rectangle to make a rectangle that is white in the middle with a black border. Did you know if you put an extra parameter, it's the border color? And it's going to draw it from x, y, and x, and y. Those aren't variables that exist. I can define them. So I can say x equals 0, y equals 0, and then end x is going to be whatever the starting x is plus the size of one of these squares. What's the size of one of these squares? It's given to me as a constant. It's equal to size. So ny can be equal to y plus size. So if I run this program, it doesn't crash, but it doesn't look like it draws my first row. So this is supposed to draw a single row. Instead of drawing a single row, even though it's run 8 times, it's done one of those things where it's drawn 8 squares on top of each other. And that's because every single time I call draw square, I'm actually ignoring R and C. R is just supposed to say, are you in this row? Are you in this row? Are you in this row? And column is supposed to say, are you in this column or this column and this column? This is column 0. This is column 1, 2, 3, 4, 5. If we print out in here, we can see what are the parameters passed to us. And I will lightly note that while getting started, you might find this to be a helpful tool to use print statements to see what information you're given. So draw a square is called 8 times. First is called with row 0 and column 0. Then is called with row 0, column 1, up to row 0, column 7. My question for you is, how could you use this changing value of column and turn that into not all the squares on top of each other, but instead all the squares laid out in a line? You have the column number. If column is 0, it tells you something about where your x should be. It should be 0. If column is 1, your x value shouldn't be 1 pixel. Instead, your x value should be all the way over here. The starting value should be over here. And that's size of one of these squares. In this case, it's 1 square. The next time you want it to be 2 squares over. The third time you want it to be 3 squares over, fourth time 4 squares over. Every single time through this loop, we're given the value of c. And actually, c tells us where the x should be. If you take c and multiply it by size, the first time x will be 0. The next time, x will be equal to size. The third time through the loop, x will be equal to 2 times size. And if we run this, we see it does exactly what we want. X is 0, then size, then 2 times size, 3 times size, 4 times size. We can go back in time and say, like, okay, when row is 0 and column is 5, we're about to draw this square. We can take that 5 and multiply it by size, which is 50. And when you multiply it by size, we end up with 250. So the x will be 250. Y is 0. End x and end y are just size plus those x's and y's, and we create this next rectangle. It worked really nicely. At this point, we've drawn a single row. And what we'd like to do is repeat that. And this is going to be a bold move, but what I want to repeat is this entire process of drawing a row. So if this draws 1 row, I want to draw 8. And to do that, I'm going to put this whole thing into a for loop. So I'm going to say for r in range n rows, repeat this. And this time, when I call draw square, I want to give it not 0, but I want to give it the changing value of row. So this is going to run 64 times. Why 64? Because every time this for loop hits, it's going to run 8 times. And this body is going to be run 8 times itself. So it'll be 8 times 8. This will be called 64 times. Let's focus on this print statement. Let's look at all the different values for row and column. Look, there's 64 different values. First, we get all the rows equals 0. That's row equals 0, column 1. Row equals 0, column 0. 0, 1, 0, 2, 0, 3, 0, 4, 0, 5, 0, 6, 0, 7. That's these ones. Then we go to the outer for loop, and now r is going to take on the value 1 because we've completed the loop once. And then you get 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7. The goal there is to draw this whole line. And then after that, row is going to be equal to 2. And the goal is that if draw square would always draw a square at the given row in the given column, this would be all that we need because we're going to call it with every possible combination of row and column. The only issue is draw square doesn't respond to r. This variable is never used anywhere in this function. R says, are you in row 0, row 1, row 2? And the value of r should be changing the value of y. So which row you're in should change what is the y location. So if we take row and multiply it by size, and recall size is the constant, which is how wide and tall each of these boxes are. Now this function doesn't just draw 1 square, it draws 64 different squares. And again, you can look at all the different values of row and column. This function gets called 64 times with 64 different combinations of row and column. If we were to look at the place where it did, let's say 6, 4. So if we go back to this moment in time, at this point, it's going to draw what's at rows 0, 1, 2, 3, 4, 5, 6, and what's at column 0, 1, 2, 3, 4. So, sorry. This is the 6, 4 one. So if we do 6, 4, it's going to draw what's in this square. First, it says, okay, what's my x going to be? Well, it's going to be column, which is 4, multiplied by 50 pixels. So that's going to be 200. What's my y going to be? How far am I from the top? Well, that's going to be what row I am. That's row 6 multiplied by 50 pixels. And then that gives me 300. So this is 300 pixels from the top and 200 pixels from the left. That's this corner. And x is just going to be this corner plus size, and y is going to be this corner plus size. And we end up with a brand new square. And there you have it. At this point, we're almost done. We're ready for the final milestone. And the final milestone is just to turn these into checkers. This part's a little tricky. Now, I don't want to focus on the trick as much as I want to focus on the function. What would be really nice is it would be great if there was a function that would just say, hey, can you get me the color? I'll tell you which row and which column I am. And then this function is your job to decide if you're black or white. And instead of filling in white all the time, I'm going to fill in with whichever color comes back. Oh, that's a funny function. This function is already defined. It didn't crash. It's going to be lower in my program. I want you to appreciate how elegant this is. This draw square was able to stay pretty clean and simple without having to have all the complexity of deciding if you should be a black square or white square. Or in this case, I use the chess.com colors, which are green and beige. Get color row column. It's one of those functions where it's great that you can use it. If you're curious how I got the solution, I'd be happy to tell you. I use a very interesting trick. If you take all these rows and columns, there's a funny thing you can do. I don't expect people to have been able to guess this, but I want to tell you the trick I did use. If you add up the row and the column, so in this case, this would be 0 and 0. What's 0 plus 0? It's 0. And here, if you add up the row and the column, you get 0 plus 1. That's 1. If you do that for every square, you get 0 and 1 and 2. The next one's 1, 2, 3, and the other one's 2, 3, 4. If you were to continue, this would be 0, 1, 2, 3, 4, 5, 6, 7. This would be 1, 2, 3, 4, 5, 6, 7, 8. Some people might notice this crazy pattern. All the squares, which are black, are the ones where the sum of row and column are even. What a crazy thing. As I said, that's a bit of a trick. The point of this lecture is about functions and returns, not about this trick, but it is kind of a neat one. And if you look at get color, this is exactly the trick I used. So if we read get color, it says, hey, if I take row and column and add them together, I can pass it to is even. Is even is basically the same as the is odd function we had. It just takes the remainder when you divide your value by 2 and checks if it's 0. Is odd, you should check if the remainder was 1. I call is even, I take the return. If the return is true, then I give back green. If the return is false, I give back beige. And actually, to make this a little bit cleaner, because is even gives me back a true or false, I can use it directly in an if statement. What a gorgeous little function. But anyways, there you have it. Drawing a checkerboard one step at a time. This was the advanced version, and congratulations on following through. I'll leave this program in the lesson so you can check it out in your own time.